Hello everyone and welcome back to the Old Machine Factory's Garage Series Season number 1. In today's episode I will show you two torn down Jaguar AJ-V8s. We will take a look at the condition of the components, the internal parts, and then we will also compare the components against each other because the engines are quite different from the factory spec point of view. So the first engine is a 4-liter naturally aspirated Jaguar AJ V8, and that has been in rain without the bonnet on, so it's not looking that nice. And the other engine is been in a flood, so that's from the 2007 XKR, and that's the 4.2-liter supercharged V8. So the engine spec is quite different from the factory, and let's see if we can find any differences between the major parts or dimensions of the engine. Then later on in the upcoming episodes I will also compare those engine components, Jaguar engine components, to other engine components, so like BMW and Toyota parts. And then I will also take a deeper look into the actual details of those components, the cams and so on. But let's reserve proper time for that in a separate episode, or maybe even 2 episodes, depending on how deep we go. But that's for later purposes or later episodes, the more detailed look. And then thing that I would like to mention also here is that I started building a simulation model from the AJ-V8 engines. I think that's something that people usually don't do when they build cars as for hobby. So I actually built already the base model, like a system level performance model of the AJ-V8 engine. And the idea is there to show you how the boost affects the engine behavior, how the timings affect that performance behavior, and so on. So let's take a more detailed look and reserve some time properly for that as well. But not many of you know that I have been actually working in an engine design team for many years, and I was in charge of the simulation group. I was the team leader for that, and then I did a lot of simulation work also by myself. And actually I'm not sure how many of the hobby drifter engines have been simulated, but actually the Black Scorpio's Turbo M50 engine has been simulated back in 2011. Performance wise, and it has been actually presented to guys from Wärtsilä. They were this technical group that was actually evaluating our work, so that has been done back in the day. But that's something that might interest a lot of people. So, and I haven't seen a lot of that shown in the hobby things. So we will definitely take a look on how the engine looks on the simulation table as well. But in today's episode we will first take a look at the AJ34S XKR engine's weight. So let's check how it looks on the scale with all of the components that are needed to basically for the engine to be a turnkey package. So let's take a look. So here we have the 2007 or 2008 Jaguar XKR engine, the AJ34S, hanging on the scale with all of the auxiliary components, the starters, AC, alternator, all of the pulleys, tensioners, coolant piping, charge air coolers, intakes, injectors, fuel rails, throttle, flaps, engine mounts, wiring looms, everything just stacked on top of the engine to see what is stud weight that we are dealing with. And actually it still has the torque converter hanging there because I cannot take the bolts off due to the fact that there is mud in the cylinders, so it's kind of hard to turn the engine. So we need to strip it down first and then take the torque converter off last. So let's see what the scale says. Let's put there some light. So it's 257 kilos roughly. That will be our starting point, and let's see what will be the end weight for the final package that we will then assemble from these different engines. Let's continue to the actual teardown of the engines next. I wanted to keep this like a story, so you can follow along the feelings during the teardown of the engines, and I will do that both for the 4.0 and 4.2. If you're not interested in the actual teardown things, just jump further in the video and check the comparison between the engine components. But I wanted to share the excitement and surprises as they came along. So if you want to take the longer route with me, let's check the 4.0 next. This is the engine that I personally pulled out from a 2001 Jaguar S-Type 4.0. So this is supposed to be a 4-liter naturally aspirated V8 from a 2001 S-Type. But it turns out it is not. So if we take a look at the engine, as you can see, the timing chain and the guides and the tensioners and everything, they have been changed. So they look like new. There's actually no markings at all in the timing parts. So somebody's been in here. And as you can see here, we have the metal tensioners. So these are the better ones, not the plastic ones that this engine should come from the factory with. So somebody's definitely been inside this engine. And then if we look at the bottom end, it's like fully rusted out. So I'm wondering at this point that has someone changed the engine, fixed it from the timing chain point of view, and then left the car to rot, because otherwise the engine looks quite nice. So as you can see here, there are even markings of the valve clearance. So someone has been measuring and probably also adjusting the valve clearances on the cylinder heads. So this has been definitely worked with earlier. And the exhaust cams seem rather nice. Also the intake cams from like scoring mark point of view, they look intact, so there are no scoring marks at all, but they're quite heavily rusted, as you can see. So I'm not sure if these are good after a proper cleaning. It might be so that already the surface has rusted through, so that there are pits in the actual profile. But we'll see. We'll try to clean that up. And anyway, after all, after the cleaning, we can still most likely measure at least the profiles, so we know that if there's a difference between those cams and the cams on the other engines that I have. But as the engine is really rusted now, I have to pull it apart and see if there's any parts that I can spare, and let's take a look at those parts as soon as I get them out of the engine. Okay, so I pulled off the heads, and as you can see, the scene isn't that pretty. So there was actually water in all of the cylinders and on both sides. So it's not looking that good. But the strange thing about this engine is that new surprises come all the time. This has actually an MLS cylinder head gasket. So this is a 3-sheet, 3-layer metal gasket, I think. And I thought that all the Gen 1 engines come with the mass cylinder head gasket. So this is definitely different than in my year 2000 S-Type. So it's really interesting to see what is actually the origin of this engine. I bet it's from an XJ because of the auxiliary components, but let's try to figure out if we can find the history for this engine from the markings on the block and the heads and so on. But let's continue further. I'll try to disassemble the bottom end next. I think we need some lubricants and rust off treatment for that. So let's continue. So as it turned out, the 4.0 wasn't in such a great condition, and actually I had to take a little time out because all of the pistons were so stuck in the cylinders. So I want to pull out one. So I put it in fuel oil and some rust penetrant, and in the meanwhile I will tear down the 4.2 liter supercharged engine. Let's go and take a look at that next. So I started tearing down the Jaguar XJR's engine from 2007 or 8, AJ34S, so the newer one with the VVTi. And like I said, this engine is actually from a car that was in a flood. So it was sold to me by a seller who said that the engine is stuck. And of course I believed him. The price was so low that I thought that I just wanted the auxiliary components, and if there's something I can use, that's a plus. So I I picked up the engine with the information that it was seized, stuck, didn't turn, and just threw it in the trailer and drove home as a happy man. Well, I haven't had time to investigate the engine that much. That's what I'm doing now. And I started pulling off the wiring loom, which goes beneath the auxiliary bracket. So I thought that I'll pull out the bracket. And the previous owner had already cut the supercharger belt just to see that if the supercharger was holding back the engine from turning. But the auxiliary belt was in place. So what I did, I took the auxiliary belt off. Here's the water pump, turns. Here's the power steering pump, turns. AC, turns. Tensioner, idler, second tensioner, all turn. Except for this one. So the alternator, that's stuck. I even tried it with a wrench and it doesn't move. And like you see, it's been rusted to the belt as well. Even the tight bend is there, so it's been rusted, stuck to the actual alternator. So what I thought, what if the engine was held stuck by the alternator? Then I came back to the back side of the engine Sorry for the mess. I have a lot of things ongoing. Where we have the starter gear here. And then I thought that I'll just pry bar it just a little. And the engine turned. Not sure if you could see. Let's try the other way as well. I don't want to turn it a lot because there's something in the cylinders. But I'm not using force at all. And the engine turns. So this is this is where things get very exciting. I'm like really excited, as I know that inside the engine there are pistons, there are conrods, there's everything inside. Nobody has opened up this engine. You can see it from the covers, and when you look into the cylinder from the top, so from the spark plug hole, you can see that there's pistons home there. So I'm just thinking that what if we have an 80,000 kilometers driven 2007 or 8 XKR engine, which is basically in a working condition. Of course it needs to be checked, but you know, if the pistons are okay, if the liners are okay, if the bearings are okay, what else? Well, the bearings you can get, but if the major parts are like okay, what if we could use this engine as well? That's a really nice thought. Let's not get too excited, but a bit. So I will now continue to strip down, and let's see what this mystery box keeps on giving us. I cracked open the XKR engine. So as you can see, I pulled off the oil pan, and I was a bit surprised because I found oil in it. So that's actually the oil that came out. And as you can see, it's pretty clean, but it has water in it. So that's why it's this like mocha latte color. But it's surprisingly close to oil still, because everything is looking clean. So there's no rust there or anything like that. This is just dirt. This is not rust. It comes off. So a nice surprise there. Then I pulled off the timing cover from the timing gear, and I wanted to show you this before I tear the engine fully apart, because we can see two differences here between the engine variants. So if we take a look at the actual timing gear side, it's really nice and clean. So even though there's some moisture in the oil, it's not too bad, even on the crank train side. So there's no rust basically at all. And then the differences that we can instantly see are: the first difference is the chain that drives the cam from the crankshaft. So as you can see, it's different from the chain that is running between the cams. And this short chain between intake cam and exhaust cam, it's a single row chain, and it's the same as in the older engines. But in the older engines we also had this here, so as the long chain. The same type of a chain was running the cam from the crank train. And in this engine they have tried to fix the problems with the longer chains. And as you can see here, we have the metallic chain tensioners, and that unit is actually the same unit that we can find in the early engines, or for the early engines as an upgraded part. So they have changed the metallic tensioners to replace the plastic ones that broke. So they definitely have tried to do some development with the timing gear problems. Then another thing that we can see here, this is from the older engine, it's the intake cam, and here you can already see the single row chain as the longer chain. And then this is the timing unit, so cam phaser or variable timing unit for the intake cam, and it's basically the same type of a internal structure as in the Vanos system. So you insert the oil pressure, and there's an internal gear inside this housing that turns then the intake cam, and these are on-off controlled. But if we take a look at the newer engine, actually this part that inserts, there's the VVT solenoid, so that inserts the oil into the cam phaser. So this part, even though it's a bit nicer looking than in the older one, it's basically exactly the same component. So that's not changed. I'm not sure of the solenoids yet, I need to check that, but I bet that those are also the same. But if we take a look at the actual cam phaser here, we can definitely see a difference in the phaser other than the gear itself. So this is like a vein pump type of a phaser. So we have some sectors between sector chambers here between the internal part and the external housing, and there's vein seals, plastic seals running along this internal side of this cover, and that's keeping the oil pressure in the chambers. And by adjusting the pressure and the volume of that chamber, we can then adjust the timing continuously in this type of a system. So that's definitely a difference between these two engines. Other than that, things are looking pretty good. Some light rust on the cams, that was something that was evident, or something that I was waiting for, so no problem there. Let's try to clean those up later. But as for now, let's continue the teardown as we have seen these differences. So, pulled off the right hand side cylinder head from the XKR engine, and I could say that we have a little bit of everything here. So in the first cylinder we have hay and stones, probably. In the second one we have mud. In the third one we have muddy water. And in the last one we have leaves and rust. So can't say that hit a full jackpot with this engine, but let's see what we can do with it. I think the rust still seems quite light, so not too bad, but let's pull off the driver's side head and then see if we can find further surprises on that side. Okay, so pulled off the head from the driver's side as well on the XKR engine. As you can see, we have a dry piston, quite dry piston, a piston with oil and leaves, a piston with oil and water, and a piston with hopefully only mud and no dead animals. It's looking quite bad, but hopefully it's only mud. But these cylinders are quite, clean, no rust or no big staining on the edges of the liner. So let's see. Next, after cleaning out the cylinders, let's pull out the pistons. I will flip the engine around and then clean the cylinders, and then pull off the crankshaft and then push the pistons up, so we can check the pistons, piston rings and liners. And as you can see, the dry pistons are quite dirty on top, and I bet that this is coming from the EGR system on the engine. So also the exhaust ports on the cylinder heads were looking quite nasty, and I hope it's due to the fact that we have the EGR in this engine. And the other reason for that kind of a content on top of the piston could be from burning oil, but we'll be more wiser when we tear the engine down to pieces and check the liners and check the pistons and rings. So let's continue forward. Let's take a quick look at the XKR cylinder heads. So these are from the flooded engine and freshly pulled out of the engine, so no cleaning whatsoever. And first let's take a look at the bearings. So the bearing caps are of course the ones that carry the load, but I have them in a box and I checked them and there's no problem at all with those. So these are, all of the bearings look clean and good surface finish there, so no problem with the bearings. Then the lifters, they are also looking quite good except for these four. So actually one is stuck open and these have some light rust on them, so have to really carefully look if the cam and the lifters are in a usable condition. The lifters, I have some spare ones, and actually it's the top lash cap which is rusty, so probably we can find some spares from the shelf from the other engines, but otherwise looks quite fine on this side. Then as we look at the exhaust ports, they are really dirty, so I'm hoping that this is due to the EGR. So otherwise the oil consumption should be quite consistent in all of the cylinders, so not really counting on that. I hope it's the exhaust gas recirculation system that makes this happen. Then as you can see here, one of the valves is stuck open because the lifter is rusted in its place, and I hope that this has happened while the engine is at standstill. So the timing has been so that this cylinder has been on high intake lift, and then when the engine has been underwater, the water has caused the lifter to be stuck in that position, and no actual interference between the piston and valve has been done or happening. So of course we'll learn more when we pull off the valves and check the seating and the stems and so on, but that's what I believe has happened at this point. Then if we take a look at the intake side, so this is the driver's side cylinder head, we can see that the intake ports are really dirty, even though this engine has port injection. So I bet that that's due to the EGR. But other than that, it's fairly good. The same goes for the passenger side cylinder head. This is actually looking even better. So no lifters stuck, some dirty lifters but not rusty ones. So this is definitely better. And also the same goes for the bearings on this side. So the bearing cap, which comes on top of the cam here, is carrying the load as the springs are pushing, and the lift of the cam is pushing the cam against the bearing cap. So that's the really the load bearing side, but those looked fine, no problem there. And the lifters seem to move, so quite fine on that side. Here on the exhaust ports, again the same story that than on the other side as well. So if the oil burning is the reason for this, it must be really consistent. I bet it's because of the EGR. Then actually from these valves it's hard to say anything, so there's still mud dripping down from the cylinder head combustion chamber side, so we need to clean that up before saying anything about that. But if we take a look at the intake side, so the same story here, dirty intake runners due to most likely the EGR stuff. So that's that. Fairly good situation on both heads. Let's see if we can clean that up without breaking the lifter tray, but or the lifter bore. But that's something that we need to check. 4.0 cylinder heads, same story here as in the supercharged versions. Bearings look okay, but actually lifters look even worse. So there has been some water in the lifter area. There's definitely some difference in the port design, and when we clean up the cylinder heads, I will check the port design and then the valves, valve sizes in the more detailed episode. But as for now, it's looking exactly the same, you know, from the outside as the 4.2 liter. The interfaces are the same, so let's not concentrate on these any further. Let's continue the struggles with the rusted lifters in the more detailed episode. I will show you if I can salvage any of the parts from these, and then let's measure also the cams later on in the upcoming episodes. Next, let's take a look at the main bearing support. So this is the bottom end of the cylinder block. So the crankshaft is located there, and these are the main bearing caps for the crankshaft. And as you can see, they are connected to each other fairly strongly, so there's a girdle design already from the factory. So very well supported main bearing caps. And if we take a look at the actual caps, we can notice that there's a color difference here. This is aluminium magnet, doesn't stick there, falls off. But if we go here, there's an iron or steel insert there. So there's additional support inserted into the aluminium. And if we take a look at the block side, the upper half of the main bearing support, here we don't have any, this is not iron, it's aluminium, so of course the load is on the bottom end, and that's where they only have added the steel or iron insert. You can find this kind of a structure, additional insert, also in the Subaru diesels, for example. But other than that, it's a fairly strong design, and there's no difference between the 4-liter naturally aspirated engine and the supercharged 4.2. So this is the same part with same 62 millimeter main bearing diameter. And this is the bottom end of the 4.2 liter supercharged engine. So as you can see, quite sturdy main bearing support structure, and actually we have oil jets, piston cooling jets in the block. So this is oil cooled piston variant of the block. Other than that, surprisingly, the liners look like fairly okay. So there's some staining here, as you can see, but it's not like you cannot even feel it with the finger or nail. So as the liners are steel liners, we can give them light honing, and then I think we can use this block. So that's a really good thing. We cannot say the same for the 4.0. So this is really rusty. I managed to get one piston out, but other than that, it's like really stuck from the rust. And actually this engine, if it was the original engine from the 01 S-type, it should have aluminium liners, at least to my knowledge. But this one has iron liners, and actually the block marking says that it's a 2003 engine. So I cannot say really anything about this engine anymore. So it's definitely not what it was supposed to be. And on the bottom end, we can see that even the conrods are like fully rusted. And actually we can see the interesting thing here is that we can see that this doesn't have the oil jets for the pistons, but it has all of the machinings for that. So there's a drilled hole, threaded hole for mounting them, and there's a plug in the channel so that the oil pressure doesn't come out. But other than that, the blocks seem quite the same, so I haven't found any major differences between these, as this had even the iron liners. But let's let it be, and let's use it as a, for example, oversize machining or machining exercise. So as they have the iron liners, let's see if we could fit a 0.5 millimeter bigger piston there, and these have the bore of 86, so basically there's a possibility to use aftermarket pistons from some other engine. Let's discuss that in the following episodes in more detail. Here we have the crankshafts. So this one is from the 4.2, that's from the 4 liter. We won't use the 4 liter one as it's really rusty, as you can see. It's gonna be some decoration in the living room or something like that. But let's look at the differences. So there's a key here for the timing gear, and this key slot, and then the diameter for this area where the gear sits for the timing chain, it's exactly the same. So you can swap from this to that the timing gear. So you could basically get the newer timing gear on the older engine. Same goes for the oil pump drive. So you have the shape there for the oil pump drive. So that's also the same diameter, same shape. Could be swapped around. Same goes for the main bearings. Those are the 62 millimeter ones in both. But on the conrod side, the 4.2 has 53 millimeter bearing or journal diameter, as the 4.0 has 56. And of course, as the bore is in the same in the cylinders, there must be a stroke difference between these two. So that's a 90.3 millimeter stroke, and that has only 86. So that explains the 2 deciliter displacement difference between the engines. Other than that, the balancing concept seems to be the same. Even the trigger wheels, everything, and the connecting surfaces at the front end and at the back end, they seem to be the same. So basically we could interchange the crankshafts from the 4 liter to the 4.2 if we also change the conrods. But that's something that we need to check in further detail if we run into a situation like that we would like to run, for example, the shorter stroke in the newer block or something like that. On the cylinder head gasket side, this is from the 4.2, and it's exactly the same gasket that we have in the 4.0, at least in this variant. I know that there are other type of gaskets in the older engines, which I thought this one was, but these both have now the 3-layer MLS steel gasket, so not a mass gasket as they say. So they are the same 3 seats in both engines gaskets, and all the dimensions are exactly the same. Also, I can show you the cylinder head bolts. So if we take a look at these are exactly the same grade. So the strength class 11.2, 11.9 of course for both. Same thread, same dimensions. So only the head is different due to the fact that they use a different tool to tighten them. But so the cylinder head gaskets and the bolts, they're same in the both engines. Then the pistons and conrods. This is from the 4.0 and this is from the 4.2 supercharged. As we can see, even though this has some rust on it, it seems that the conrod is actually, it seems like the material is also the same, and the shape is definitely the same from here to here. So, but on the bottom end we have the same bolts, same grade, same dimensions for the bolts, but here we can see that the 4.0 has bigger diameter for the bearing. So this had the 56mm bearing and that had the 53. So the supercharged version has a smaller bearing. As for the piston, the basic dimensions are looking quite the same. So piston pin diameter is the same. It might even be the same pin, looks like it. These areas here, the dimensions for between the piston rings and the ring thicknesses and so on, they look like they are the same. From the bottom of the piston, this was uncooled, so we didn't have the piston cooling jets in the block. But also this one looks surprisingly simple. So they are just spraying the oil to the bottom of the piston without any gallery. As in some of the engines we have these kind of holes which inserts oil to the cooling gallery on the top of the piston or bottom of the piston, but we don't have that in these. Then of course if we look at the top, this has the compression ratio of 10.5 to 1, and this has a lower compression because it has a bowl, so that's 9 to 1 compression ratio. And the material seems different here, so these probably, it seems that it's a better die cast basically, so the material, it has been changed there, but it doesn't seem like it's a forged piston like they say. But let's check the details later on. Then let's take a look at the oil pumps. So when we place them each other on top of each other, we can see already that the 4-liter pump is much smaller than the 4.2 liter supercharged version. These mounting bolts actually are the same, those holes and that one, but that is different. So there's some kind of a mounting difference with that bolt, and actually the mounting interfaces that we can see on the block, they are exactly the same. So basically it would be possible to retrofit the newer bigger pump also to the block, at least from what I've learned now. And if we take a look at from the front side, so actually this is the way the pumps are hanging there, we can definitely see that there's a difference. As the turning ratio is the same, I bet that has a bigger gear inside of it. So, and then the placing of the pressure relief valve, that's a bit different, but anyway, there's definitely a difference in the design of the oil pumps. And as you remember, this oil pump will pump the piston cooling jets, and I think that's the main difference. And the other difference is that the cams are continuously variable, so they must have taken that into account in the oil flow. So you always have the possibility to adjust the cams with the oil flow. That might be one of the reasons why the pump is bigger. in the newer supercharged engine. Then, as we saw that there is a difference between the cams and the cam phasers, these are the solenoid packages that provide the oil from the cylinder head to the actual cam phaser sprocket through this section here. So that flows the oil inside the cam from the cylinder head. And as you can see, the mounting phases are the same. So actually you could, you know, switch these from an engine to another. Actually the solenoids, actually they also look the same, and the same goes for the connector. Unfortunately this one has a broken connector, but it's exactly the same looking connector than in this one. So you could swap these around as well, from there to there. But what is the difference? It's here. You can see that this has only a small hole and this has a bigger hole, a really large hole, and it's like a huge flow port. And this is from the continuously variable, and actually it says FOMOCO here. So it's a fourth part. But anyway, as you can see that this is definitely, the cam phaser type is different and it's requiring more oil flow. So they have designed this differently than this one here. So this has only a small hole there and another one there. So that's giving us a hint that together with the bigger oil pump, there must be a bigger flow to the continuously variable cam phasers. Let's take a look at the water pumps and their drives. So the pulleys for the water pumps, they are exactly the same. So dimension exactly the same, the diameter exactly the same. Anyway, same part. As for the crank pulley, it's the supercharged version has a bit bigger pulley, so just a tiny bit bigger, but not much. So the water pump turning ratio is quite close to the same. Then as we look at the pumps, first I thought that there's a bigger difference because this engine, or this pump, is from the 4 liter. It doesn't have a split line here. So on this phase there's no split line. This pump is casted so that actually this black part comes out from that seam, and then the whole housing is casted in one piece. And in this case, this is the supercharged version, we have a split line here, and it's bolted together, this two halves of the pump. And I think that's just because it's much easier to cast that. So I can open this up a bit so we can see that it opens up from here. But I think that's just for manufacturing reasons. Otherwise the pumps look exactly the same. So the impeller is definitely the same, and then all the dimensions look exactly the same. So I cannot at least see there a big difference. And that's it for the water pumps. So I said that I'm not going into details with the parts, but there's something that I want to really show you. So this is the lifter from Jaguar. Oh, both engines have the same lifter, same diameters, everything is the same. And if we put this on a scale, it's weighing somewhere around 31 grams. And this is actually an aluminium cup, so it's aluminium. And it's funny because of course the lash cap is steel, so that can be taken off. and there's a steel insert there for the valve stem, but as you can see here, maybe it's an aluminum cup which has as the bearing surface. This is the sliding surface against the bore of the lifter, so it has a really thin steel sleeve on top of an aluminum cap or cup. So let me show you. If I put it there, from this side it sticks, but if we go here, it doesn't stick. So it's not magnetic, so it's an aluminum cup with a steel sleeve on top. That's interesting, and it's really light, so cool piece. So how to summarize the mess in the garage? So for the 4.0 we could probably use the crankshaft conrods, but as for the pistons and piston rings, they are basically gone. Liners need to be bored to a oversize, so probably we could rehearse the oversize things with that block, but as for now, let's put that aside and concentrate on the supercharged engines. For the heads, I will definitely try to clean them up, save the lifters and the cams, at least for measurement use. But then, as for the 4.2 liter 34S engine, I'm really excited. The bottom end looks really good. Bearings, no problem. Pistons, no problem. Piston rings, all good. The only thing was the staining on the liners, but I think we can get away with the light honing with that. And the biggest issue with that engine in overall is these lifters and then the cams. So we need to check if we can clean those up and use them so that they wouldn't break because of the broken surfaces on the cam profiles or on the lifter side, or if the lifter bore is rusted so stuck that the lifter doesn't come out without any force. That might be a thing that forces us to leave the heads unused. But as for now, I'm really hopeful and positive about this HA34S engine. That's it for this week's episode. In the next episode, we will take a deeper look into the components. We will measure them, try to clean them. I will show you the things I do with them, and then let's try to pick up also the measurements for building up the simulation model. So sorry for the long episode, but I hope it brings a lot of information to people about these engines. So like, subscribe, leave a comment or a question. Let me know what you think about the engines. Let me know if there's something you disagree about on my remarks, and I hope to see you in the next video.